in progress. Okay, Assalamualaikum and a very good morning. Masih morning Today is 8th of November already, 8th of November 2021, and we are in dynamics class, and today we're going to go into topic chapter 2. Okay, so are you ready for topic chapter 2?
Yes.
Okay, good. All right, you're ready for topic chapter 2. Okay, so we are in topic. Oh, tebalnya apa ni? Okay. Okay, so we're in topic chapter 2, which is on kinetics of particles. Okay, do you remember what is the difference between kinematics and kinetics? Do you remember, guys? What is the difference?
Force.
Yes. So now we are doing kinetics. So when we're doing kinetics, it will involve forces. So let's just write down. So make sure you have your pen, book with you and write down. So kinetics is it deals with the relationship between the change in motion of a body and the forces that cause this change. Okay, so that is for kinetics. So kinetics, so when you hear the word kinetics, it deals with the relationship between the change of motion of the body, the change of motion of the body and the forces. So the motion of the body also change, and it's due to the forces involved. Okay, so that is what is on kinetics. Okay, so for kinetics, the basic kinetic that we use is we're going to use Newton's second law. So do you remember the formula for Newton's second law? What is it?
F equals to ma.
F equal to ma.
Yes, F equals to ma. So we're going to use the Newton's second law. So in the Newton's second law, it says that the unbalanced force of a particle, unbalanced force that acts on the particle will accelerate in the direction of the force with a magnitude that is proportional to the force. So it means the particle that we are going to study, dia akan accelerate in the direction, in what direction? In the direction of the force, okay? So the magnitude akan, the answer, the magnitude will be proportional to the force, okay? All right. So this law can be applied based on the unbalanced force F. So itu adalah F, and measuring the acceleration A. So usually for topic kinetics of particles, the question usually asks us to determine the acceleration. They can ask us to determine the velocity and all the other parameters lah, acceleration, velocity, and also position lah, semua tu lah. So basically, the question is very similar lah. But the important thing is they relate a lot with the acceleration lah. Okay, so for this formula, m is the mass and a is the acceleration lah. Okay. Okay. So, for example, can you give an example that has kinetic and an example that is related to kinetics of particles? Can you give me an example that you understand, that you can relate, that is involved kinetics of particle?
Cycling.
Cycling. Okay. So cycling, okay. But cycling, okay, let's say cycling. Okay. Okay, sekarang ni tengah hot kan, cycling kan. Okay, now macam mana nak Okay, boleh lah. Okay, cycling Ni seat dia, okay. Ni cycling Okay, mata sikit. Okay, hidung mancung sikit. Okay, so cycling. Okay, cycling is a good example, but it's similar like before in kinematics. The difference is that kita assume they're cycling along a road, tapi there is a force, initial force due to the mass of the person. Let's say dia tengah cycling, tiba-tiba dia sudden brake, kan? And then dia ada something yang causing dia to resist the brake, the friction between the tires. Okay, so mungkin ada friction. Dia going the direction going to the right, tapi because due to the tires and then dia tekan brake ada friction. Okay, that is okay example. Okay, all right, good. Okay, so let's start to do this. So basically for topic kinetics of particle, kita akan guna Newton's second law. Because why Newton's second law? Kita akan define mass dengan mass, which is the weight. Okay, and basically kita what we will do is kita nak analyze the acceleration of motion of the particle. Okay, using using different types of coordinate system. Okay, so nanti kita akan go through the different types of coordinate system. Okay, now, so when I mean a different type of coordinate system, it means for topic kinetics of particles, you punya first step is you need to identify which coordinate system you want to use. It's very similar to kinematics. Okay, so you have the rectangular coordinate system. And you also have the non-rectangular coordinate system. Sama, okay? And you understand the rectangular coordinate system is for rectilinear. And the coordinate system, non-rectangular, is for curvilinear this time, okay?
Alright, push back, push back.
All right. So for the rectangular coordinate system, what it means is we're going to use the XY direction. Okay. So what it means is tanya ya. So what it means is for the rectangular coordinate system, we need to resolve the system using the Newton's second law, which is F equals to ma, in terms of x and y direction. So you will have summation of forces in Fx, and you will have the summation in forces in My. Okay, so this will be Fx and this will be Fy. For the non-rectangular coordinate system, we will also be using the same thing that we learned before. Do you remember? One is the normal and tangential. And the other one is radial and
you should use
yes, transverse. Okay, so you remember that. But now we're using the rectangular coordinate system. Sorry. The normal and tangential. So let's say we have a path like this. This is our particle. So you have, oops, not straight line. You have to draw the tangent path. And you have to draw the normal path. So it will be the same. But the difference is this one will be summation Ft. This one will be summation Fn. Same juga untuk radial and transverse. So for radial and transverse, you have to do the same. Okay. All right.
Just try. Use your gadget to support me. Use your gadget.
So it will be the same. Okay. Summation forces Fr and summation forces F theta. So it will be the same. Okay. Okay, all right. Okay, but today, for today's class, we're going to focus on the rectangular coordinate system. Okay, so just that you are alert for topic kinetics of particles, you will be almost similar with how we did for the kinematics, but now we're going to use Newton's second law, which is F equals to ma, but we're gonna do for the rectangular coordinate system today. But you just need to be aware for Newton's second law, we also have the non-rectangular coordinate system, which uses the normal and tangential and radial and transverse. Because you have learned this during kinematics, you're gonna find it easy for topic chapter 2. You're gonna find it very easy, okay, because you already understand the concept. So for today's class, we're gonna use Newton's second law for the rectangular, using the motion that we're gonna resolve for the rectangular coordinate system. Okay, are you ready?
Ready?
Okay, ready. Sekejap, where is my notes? Okay. So for the rectangular coordinate system, we'll do for the rectangular coordinate system.
Tahu tak? Kan saya ada tunjuk kau Facebook kan? Yang ke Aeon tu kan?
Okay. You guys are copying, right? Huh?
Yes.
Okay. So for the rectangular coordinate system, so usually the particle will move, and then we need to resolve it in the XY coordinate system lah. But for example, sometimes the particle moves, and when the particle moves, kita resolve it in the XY coordinate system. So we ada X, Fx, and Fy. And sometimes we also have what you call FZ. Okay. Alright. So usually you akan buat summation forces macam ni lah. Fx, sama kosong pula. Fx sama dengan MAX, and then Fy sama dengan MAY lah. And kalau ada FZ sama dengan MAZ lah. But usually we focus on what you call 2D dimension lah. Okay, alright. So usually if you have a coordinate system macam ni, mesti ada apa? X aksi dia kan? Okay, let's say this is I, this is J, this is K contohnya lah. Okay, I, J, K. Alright, okay. So now let's do for the let's understand this. So let's say we have a particle here, and there is a lot of forces acting towards it. Okay. We have forces acting towards it. So this is F1, F2, F3, F4, F5, F6. So there are a lot of forces acting on it. So all these forces, you have to come up with one resultant force lah. Okay, so there will be one resultant force. You have to equate all the resultant force to be one. Okay, so this is how you draw the free body diagram. So the free body diagram will equal to the kinetic diagram. So the kinetic diagram is what you call MA lah. So this is free body diagram.
Yes, thank you. Oh no!
And this is the kinetic diagram. Okay, so in any question that is related to dynamics, you will need to draw the free body diagram and kinetic diagram. Okay, all right. Now let's make sure we know how to draw a complete free body diagram. Okay, let's draw a free body diagram. Okay. Okay, let's say we have a block here. Okay, and then we have a force P pulling the block. Okay, now we need to draw the free body diagram. Okay, since there is a force P, this block will have a mass. Okay, what is the mass? The mass is the weight. Weight is equals to mg. It means the mass multiplied by the gravity. Gravity, which is 9.81 meter per second squared. Okay, now for this block here, which is the direction of the mass? Which is the direction of the weight? Let's say I have two diagrams here. Okay, can you tell me which one is correct? Okay, let's say that the first one, the weight is pointing downwards like this. And then the next one is the weight pointing downwards like this. Okay, let's say this is figure 1 and figure 2. Which figure is correct?
Figure 1.
Yes.
Figure one.
Figure 1 is correct. Figure 2 is incorrect. Okay. So you need to make sure you draw. Okay. All right. Tapi somehow, even though I have explained this many times, ada juga student yang silap. Okay. The weight will always be pointing downwards. So let's say whatever direction is your particle, if your particle is like this, then the weight will be pointing like this. Okay, will be like that. Even though I've told this many times, mesti ada juga yang student yang silap tulis direction. Please don't make sure that you are not that student. Yeah. Okay. Now, so you have a weight now because this particle is stepping on a platform, a surface like this. To counterbalance it, you have to have a normal force. Okay. Now, which is the direction of the normal force? Okay, let's say you have a normal force. Is the normal force pointing like this? Or is the normal force pointing perpendicular to the surface? Let's say this is figure 1, this is figure 2. Which one is correct?
Figure 2.
Figure 2.
Huh? Yes, figure 2 is correct. So you must know how to draw the normal force. So the normal force will be pointing perpendicular to the surface like this. This is the normal force. Okay, now. And then if you have a box like this, which is pulling it upwards, it means the acceleration is going up like this, right? So what is there a force that is resisting the force going up?
Yes.
Yes, friction.
Yes.
Friction
So
force.
the friction. So the friction force, let's say you have a force pulling up like this. Which is the correct diagram? Oh, sorry. Which is the correct diagram? Force P. Which is the correct diagram? It means the acceleration is going up, eh? The friction should be going up as well as the direction of the acceleration, or should it be opposite?
Wait, there's a special offer.
Figure
Opposite.
2.
So is it figure
Opposite.
1 or figure 2?
Figure 2.
Figure 2.
Figure 2, okay. This is very important because if you make a mistake in drawing, you won't get it correct lah. So
Alright, should we change colors?
okay, now since we need to resolve it according to the XY coordinate system, now the XY coordinate system must be in the direction of the plane of the force. So the direction of XY will be like this.
Oh, that means we got another block.
So what you need to do, you must check, are all the forces in the direction of X and Y? So let's check. Okay.
Just say.
Now, is force P in the direction of X?
Yes.
Or Y?
Yes.
Yes.
Is force N in the direction?
Yes.
How about weight?
No.
So what does it mean? You need to resolve. So if you resolve, you need to resolve in X and Y. But how you resolve, the direction must follow the direction of W. For example, if W is pointing like this, the resolve should be like that. If it's pointing like this,
I think this is perfect. We're gonna win.
it should be resolved. How should it be resolved? Like that.
Yeah.
Do you understand?
You just one chance.
The direction.
You're gonna get a pick.
You cannot do,
Yes.
you cannot have a direction.
Like
Hold on.
we have to win like 5 more games.
Okay.
No.
You cannot have this kind of direction.
Alright, protect me.
Okay. This direction is incorrect.
You're gonna die.
Okay. This is correct. Okay. All right.
I'll
Now.
protect you.
Okay. So when you resolve it in that direction, okay, in the horizontal direction, will it be sine cos, W sine cos, or will it be sine W sine cos? Sorry, ya Allah. Will it be W sine theta or will it be W cos theta?
Sin theta. W sin theta.
Okay, how do you know? Okay, it will be W sine theta. This one will be W cos theta. Okay, another student from another class wasn't sure, so this is what I taught the student lah, how to make sure. So let's say your box is here, and then this is your direction lah, you nak resolve kan, but this is your theta. So what you do, you redraw the direction.
Get ready. This is
So if this is theta, this will be beta. So this will be theta. So the one closest to the theta will be cos. And the one further from theta will be sine. That's how you remember it. Okay? All right, for those that are confused lah. Because this one is 90 degrees. This one is 90 degrees. Okay, so kalau ni theta, ni beta, ni theta, ni akan menjadi beta balik lah. Okay, that one is the way for you to confirm So, okay, siapa yang confused, lukis balik lah dekat point tu untuk dapatkan kepastian kat mana theta tu. Theta tu. So, if you notice here, the theta is here. Because sometimes dalam kelas dia tak bagi theta, dia mungkin bagi angle ni. Faham tak? Nanti you confuse. So bila you confuse, you ambil theta value dia bagi je. Padahal is the other value, is the other angle. So kita tak nak kesilapan tu berlaku Okay, good. Alright. So you have managed to resolve all the components, which is correct. Okay, good. Okay, jap. Let me wrap this so that ada space. Okay.
Protect me.
Okay.
Protect closer.
All right. Now, so this is what you call the free body diagram. This is what you call the. Okay, dah tulis dah kat bawah tu. Sorry. This is what you call the free body diagram. Now, the free body diagram will equal to what?
Kinetic diagram.
Yes, will equal to the kinetic diagram. So since the acceleration is going up, let's say is pulling up here, so our kinetic diagram will follow here. M A. All right, so this is our free body diagram and kinetic diagram. So now we need to write the equation involved, okay, in the free body diagram and kinetic diagram. Okay. Okay. Sekejap Okay. 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 Azim. Okay, you need to write the equation. Okay, let's write the equation together. So fx equals to positive, go in that direction, equals to max. So in that direction, can you give me tell me what the equation is in fx direction?
Negative W sin theta.
Okay, tak cantik lah start dengan, okay, boleh lah. Negative W sin theta lagi plus
P.
ada plus P. Ada lagi
Plus P.
plus P lagi
Plus A.
apa
Acceleration.
tak, ni free body diagram.
Oh. Negative F.
Okay,
Friction,
negative friction force. Okay, ini adalah friction force. Okay, friction force ialah apa? Coefficient of the friction multiplied by N. Okay. Okay. Minus friction force equals to M
MA.
MAX. Okay, good. So that is our equation. And then kita tahu W sama dengan MG So maybe you want to replace all the information. Negative mg sine theta plus p negative mu kn. Okay, equals to max. Is that all the information? Betul tak? Okay. Now, next is for the friction force. Sorry. Next is the summation force in the y direction. We're gonna assume positive upwards. Okay, can you tell me what we have?
N.
N lagi. Siapa yang tekan N tu dia on mic N. So dia off. Cubalah teruskan ayat boleh tak? N. Lepas N apa?
Negative W cos theta.
Lagi. Jangan off mic lagi. Lepas tu? Tak ada dah?
Dua je. Dua je.
Equal tu?
MAY.
Okay. Ada ke AY dari sini? Dalam gambar ni? Dalam gambar kinetic diagram ni?
Tak ada.
Tak ada. So dia sama dengan? Kosong. Faham? Tak ada. Sebab dia hanya dalam arah MAX saja. MAY tak ada. Okay. Okay. So dia sama dengan kosong. Okay. So this is the equation. So sekarang ni my question is calculate the acceleration. Okay. So you have to calculate the acceleration. So normal force sama dengan W cos theta. So kalau I ask you to calculate the acceleration, all you need to do is acceleration AX equals to bawa ke sebelah semua.
Alright, get ready.
Okay, ni sama dengan mg cos theta divided by m. So itu adalah acceleration lah. So in case the question asks you to find acceleration, this is what you have to find lah. Okay, faham? Alright, boleh?
Boleh.
Okay, sebab ni dalam unknowns. You have to be prepared untuk questions yang given dalam unknowns. Dia macam ni if during the test or exam, if the thing you have sometimes ada yang dia bagi dalam bentuk unknown ataupun sometimes dia bukan unknown, you kena solve tapi you stuck masa during the exam. You jangan berhenti, you teruskan je, you bagi je jawapan apa bentuk tapi dalam unknowns. Faham tak? Saya just tak nak you berhenti dan stop. Okay, just continue. Okay, continue and finish it. Okay, alright. Now, okay, are you ready for doing the next question related to this topic? So you understand how to, the important thing is you understand how to draw the free body diagram and you know how to draw the kinetic diagram. You know that you, what kind of equations that you can come up with in the fx direction and fy direction. Okay? Alright, so now let's start. Okay. Boleh guys?
Boleh.
Okay, salin ya. The 50 kilogram crate, okay.
I'll distract the friend. Oh, I guess this friend is worse than you. Our opponent is worse than you. Yeah, the penny is worse than you. You're better than that penny. Yeah. Are you angry? Help! I'm gonna die. Wait, don't forget the spray over there. Not on my watch. Oh, we're gonna win! Run, 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 run! Don't go near the friend. Don't go near the friend. Wait, let me kill it. Too late. Alright, there. This is problem. And the good Pulley is shelly because it's a bushy net. The fire ends green, you know. Don't use penny. I think you should use jet. Alright. Change your gadget. No, I change your stuff. Alright, ready.
Okay, salin soalan ni. Okay, and then try to answer and then we discuss within 1 minute. Tell me after you finish. Boleh?
Boleh.
Boleh doktor.
Okay, kejap. I just nak ambil air je. I will be back
No. Protect. Well, I hit Oh! Left. There. Seriously. I think we have a bad start. I can buy the truck. I'll use something okay? It's fine. I think you should use Rosa. Alright, ready that. Yeah, I'm here.
Hello, I'm back. Are you back?
Ready?
Hello.
Oh, okay.
Dah ke? Dah. Wah, dah siap dah. Hebat. Good. The 50 kilogram crate rests on a horizontal surface for which the coefficient of kinetic friction is mu k 0.3. Okay, so the crate dia tarik ke arah kanan lah. So kita tahu acceleration dia moving that way lah. And then the kinetic friction is dia ada kinetic friction lah. Mu k lah. 0.3. So since it's pulling that way, we know the friction force will be the opposite direction lah. Lagi satu, you need to draw the weight because dia ada berat. What is the weight? The weight is 50 G lah. Tahu tak kenapa 50 G? Sebab mass dia kan? Okay, so 50 G berapa? Can you please calculate siap-siap for me? 50 times 9.81 berapa?
490.5 Newton.
Okay, Newton, good. Okay, so then you have the weight and then you also have the normal. What else you have? Okay, so done lah. But the force P is not in the direction of the X and Y axis. Sebab now our direction is this way. Betul tak? So it means you need to resolve. So this one will be P cos theta. This one you resolve. Dia akan jadi P sin theta. Betul tak?
Different Oh!
Okay. So this one will equal to what?
We're gonna wait.
plus dia akan equal to kinetic diagram, betul?
Jackie, stop.
This is free body diagram. Next equal to?
Kinetic diagram.
Okay, so what is our kinetic diagram?
Oh! Edit
M?
Pro.
A. Understand? Boleh tak?
Alright, then. You need to wait
Hmm.
two more.
Okay, now. So what do you need to do? You need to write the equation.
Berapa?
So kita ada equation fx.
Show me.
Positive. So can you tell me what do you have? Tolong, someone.
You could.
Megat.
I told you.
Give me the equation, Megat.
Oh my god.
Megat, are you here?
Yes, madam.
Tolong Megat, berapa?
Now, don't use
Untuk FX doktor.
Yes, in fx direction.
Minus FF
Use Rosa.
Okay, minus ff
Keep using Rosa.
plus P cos theta.
Yes, lagi? Mana lagi?
Where did that?
Plus P.
Hah? Kenapa plus P? Tak ada. You have just look in the x direction. This is in the x direction and this one in the x direction. Dah tak ada dah. Kan?
Yeah.
Tu dia.
Equals to what, Megat?
Yeah, you should.
MA.
Okay, M kita equals to MAX. Okay.
NX.
Okay, so negative friction force adalah apa? Remember, friction force adalah mu K N. So you can replace friction force dengan mu K N plus, okay, terus gantilah 400 cos 30 equals to mass berapa? 50 AX. Okay, alright. Okay, now. Okay. FY pula. Okay, FY pula siapa? Nak bagi nama ke? Okay, FY buka. Siti Aisyah. Siti Aisyah, are you here? Siti Aisyah? Siti Aisyah. Siti Aisyah, are you here? Dah hilang dah? Siti Aisyah binti Arbain. Where are you? Siti Aisyah? Mana Siti Aisyah? Hilang dah? Maisara, mana kawan you? Left dah?
Internet dia kot.
Okay, tak apalah. Maisara, you bagi tahu. Maisara bagi tahu. Give me the equation in the y direction. Maisara?
Positive N.
M?
N.
N, okay.
Negative W. Plus P sin theta.
Lagi? Equals to?
0.
Yes, 0. So N
What are you doing?
minus mg plus, okay, elok terus gantikan kot. Tadi dah calculate kan, M tu apa? 490.5 plus 400 sin 30 equals to 0. Okay. Alright, betul ke kita dah ni? Okay, ni kita kena simplify lagi. 0.3 N plus 400 cos 30 equals to 50 AX. Alright, okay. So, from here what you can do? You can find N dengan A, betul tak? Ni ada equation. Ini second equation. Can you find me what is N and what is acceleration?
Well, you lost the challenge. But are you going to use it?
Okay. Can Nur Faiz, Muhammad Nur Faiz bagi jawapan untuk N dengan acceleration. Nur Faiz. Muhammad Nur Faiz, are you here?
Ada madam. Sekejap,
Bagi I answer, betul.
That's gonna be somewhere at March or July that you're gonna buy. Now, I think you should change your wallet. Yeah. Not that guy. Pulley.
And 290.5.
Betul.
Change your gadget.
Newton
Yeah.
A,
Change your stuff over.
coming soon. A.
Are you sure? Just risk your bit. Do you think you can do it?
5.19
Okay.
meter per second
No,
square.
two more.
Okay, now. That is the normal and acceleration. Now, question dia minta apa?
Oh, kill, we got kill.
Velocity.
Okay. So, for the velocity, because benda ni constant, bila acceleration adalah constant, you can use this formula.
Never mind.
And then because dalam soalan ni dia kata the create rest kan, the create rest on horizontal surface. So maksudnya before dia bergerak dia start from rest. So kita can say that V naught sama dengan kosong lah. So the velocity equals to 0 plus acceleration yang you dapat tadi tu, which is 5 point berapa tadi?
Alah,
19
bro.
multiply by time taken mana? 3 seconds.
I think.
So what is the answer for velocity?
Wait, I only have one last chance. Apa that? You have to try this. You have to wait. Pass the ball.
What is the answer?
15.57.
Help. I died.
Okay, in that direction. Okay, so that is the answer. So senang Okay, alright. But you must remember. So this is the way, the method. Number one, you must make sure you know how to draw the free body diagram and the kinetic diagram, and then you need to resolve the equation according to the direction, and then once you get the acceleration, you can find the velocity. Senang je. Okay, now we're gonna do one example yang ada pulley dengan cable, so that you know how to do if the question ada pulley dengan cable.
3, 2, 1, go. Whee!
Okay. Now,
Cepat.
boleh? Can we do? Are you okay?
Yes.
Yes.
Alright,
Okay,
now we
good.
have to play defense. What is Ada mandi dah.
Alim,
Alright, Tef. One more win. Ada mandi dah. Oh, that nothing. Who's this? What's it? Cakap siapa ni? Alright, Tef. Lepas kita menang ni, we're gonna get a mega box and the pin.
you all dengar ke suara anak I tu?
Dengar.
Azim, semua orang dengar lah.
Okay.
Dia group A. Group A kan sekolah minggu depan. So dia kat rumah. Okay. Okay, and record. Adakah suara dia mengganggu?
Tak pun.
Tak.
Suara saya kuat lah.
I have to mute for a while, but I can.
You can hear me kan?
Yes.
Okay. But I cannot see you. But you can see me? Kan dah tutup kamera. Oh tak, ada. Okay. Okay, simple je soalan ni. Tapi the important thing is you understand the concept. Kenapa I buat macam tu?
Let's go. I got 4. Oh, I got Poco.
Okay, now. Okay, dah habis salin dah? Let me know. Let me know after you have finished copying. Dah, okay. The 100 kilogram block A is released from rest. If the masses of the pulley and the cord are neglected, determine the velocity of the 20 kilogram block B. So kat soalan ni pun sama, dia minta velocity. So velocity. So basically we can use this formula to find the velocity. And we know V naught is 0 because it's released from rest. But right now what we need to do, T kita dah ada, 2 seconds. But what we need to do is find the acceleration. But in this question, the acceleration ada dua. Because kita ada dua block. Dua mass yang causing motion. Okay, satu block A dengan block B lah. Okay, block A is 100 kilograms. And then block B is 20 kilogram lah. Okay, alright. Soalan ni dia nak velocity of block B lah. Okay, alright. So, how are we going to solve this problem? Macam mana kita nak solve this problem? Okay, macam mana? So, basically kita kena yang causing motion is block A dengan block B lah. So, we need to draw the free body diagram dengan kinetic diagram lah. Tapi kita kena separate it because we have two things that is causing motion. One is block A, one is block B. So, we do for block A first. So, when you draw for block A, so draw. Okay, sorry. So draw for block A. Now, these cables are behaving in tension. Okay. These cables are behaving in tension. Cara you nak draw dia, let's say this is the joint kan kat sini. Dia pulling the joint. This is the joint here, dia pulling the joint. Okay. Now, so you need to label it. There's many ways you can label it lah. Kalau you labelkan it as tension, bawah ni pun akan jadi tension tapi dia jadi 2T. Okay, you understand? Or let's say this is the cable and then you tiba-tiba labelkan ni sebagai T dulu. It doesn't matter. You will get the same answer. So this one will be half T. This one will be half T. It depends. Both you can use. Both boleh. You will get the same answer. Okay? Alright, it's how you label it. Okay, understand? Is the way how you label the tension cables. Macam mana you nak start labeling it. Okay? Alright, but now we need to draw the mass, okay, of the block. Okay, so block A. Kita draw block A. So this is block A. So block A, bila kita nak draw the free body diagram, of course akan ada weight W, betul tak? Yes? Kan? And dia akan ada tension cable ni. Tension cable dia berapa? 2T ke 1T? Let's say kita refer to this first one. Dia akan jadi 2T lah. Okay. So this is our free body diagram lah. Okay. And then we have a word equal to the kinetic diagram. Okay. So the kinetic diagram, let's say kita assume pointing downwards positive macam ni. Okay, alright. So due to this, kita kena come up with a force, summation force kan. So our summation force will be Fy lah. Betul tak? in the direction of Fy sebab Fx tak ada. Betul tak? Understand?
Yes.
Okay. And then if you want your Fy to be positive, you assume the direction to be downwards positive. So it means kita punya vertical direction ni, Fy ni, you can assume upwards, you can assume downwards. Tapi if you assume downwards, baru MAY ni positive. Faham tak? Is how you assume it. It means you can assume it the other direction, but in the end nanti kita akan counterbalance lah. Kejap Okay, kejap Hello? Hello? Ada kelas. Kejap lagi nanti habis. Kenapa? Dapur dah kat I. And then student Upta I dah upload semua answer for tutorial dalam Evans. So kalau student nak buat tutorial questions tu, dia boleh tengok jawapan lah. Dah ada dah. Lepas tu ada benda lagi nak cakap tapi maybe after class. Boleh? After class. Tak, kenapa tak jadi KP tu Okay, tak apa. Okay. Alright. Nanti after class call you. Bye. Okay. Hello? Hello. Can you hear me? Hello? Okay. I continue. Sorry, tadi ada call. Okay. So, it means you a direction of positive, negative ni you boleh assume. So, let's say tiba-tiba you dapat jawapan acceleration to negative. It means the direction yang you first assume tu the opposite lah. Faham tak? Tapi sekarang ni sebab kita nak letak equation kita macam ni, kita purposely letak our vertical direction going downward sebab kita nak kita punya acceleration ni positif. Okay? Boleh? Ini assumption saja. Boleh tak? Boleh
Boleh.
Okay. Alright. So, blok kita ialah So blok kita WMG, M kita 100 kali G berapa? Senang je lah, 900 Newton So if we write the equation, it will be 981 positive minus 2t equals to 100 acceleration in y direction. Tapi our acceleration in y direction, because kita dah tahu blok kita dalam blok A, kita can write acceleration A. Okay, now can you try and do for block B pula? So let's do for block B pula. So kalau kita look at block B, dia punya ni, dia macam ni, dia ada T lah, kan? Macam tu lah. Sebab ada satu je lah kan, T. Okay, so basically kalau kita nak draw free body diagram for block B, dia sama. Weight turun bawah macam ni, and then tapi dia ada T saja, dia tak ada dua T. Okay, and then this one will equal to, okay, sama M, A, B. So if you want to write down the equation, also it will be the same. Kita boleh assume positive going downwards. So dia akan jadi W. So what is the mass for block B? 20 Okay, 20 kali 9.81 berapa? Berapa?
96.2.
Okay, Newton. Okay. Alright, so kalau kita write the equation, it will be 196.2 and then minus T equals to 20 acceleration B. Okay. Boleh? Alright. So now you have two equations. Okay. You have two equations, tapi you ada berapa unknown? 3. Perasan tak? So macam mana nak solve ni? Kita kena ada another equation lah. Sebab unknown you adalah T, acceleration A dengan acceleration B. 3 unknown. Nampak? So bila you ada 3 unknowns ni, tak boleh lah. So kita nak mudahkan kerja kita, kita kena eliminate number of unknowns ni. So macam mana kita nak eliminate? Kita boleh guna one more equation based on the length. So since kita ada motion block A, kita boleh namakan ni as what? SA. And since kita ada block B, kita boleh namakan panjang length ni block B. Okay, so kita akan dapat SA plus SB equals to apa? Total length. Tapi dekat sini ada SA ada berapa tali?
Follow this guy.
So you must letak 2. Okay. Macam mana kita nak eliminate number of unknowns dengan equation tu? Cuba you tengok. Sekarang ni equation kita ada T, ada A. Mungkin acceleration ni lah. So kita tahu kalau kita differentiate, kita akan dapat velocity. Kalau kita differentiate lagi, kita akan dapat apa? Acceleration. So maksudnya 2 acceleration A equals to negative acceleration B. So ini lagi satu third equation. So this third equation bolehlah gantikan dalam equation ni supaya dua-dua ada unknown yang sama. Nampak tak guys? Nampak tak?
Oh, I see her.
So the third equation ialah
Right.
kita boleh cakap okay, 2 acceleration A equal to negative acceleration B kan? Ataupun lebih cantik kalau kita buat
Still alive.
kita buat macam ni lah. Acceleration B sama dengan negative 2 acceleration A. Betul tak? So this is our third equation lah. So acceleration B ni you gantikan dengan negative 2 acceleration A, you akan dapat 2 equation dengan acceleration A. So nanti mudahlah you nak solve. So you akan dapat first equation yang ni.
Where's the other guy?
The second equation you akan dapat acceleration B akan jadi negative 2 acceleration A. Betul tak? So sekarang ni ini adalah the other equation. Let's say equation 4. No. Bukan equation 4. Okay. So ni adalah equation yang pertama tadi. Ini adalah equation yang kedua tadi. Tapi kita dah make it dua equation dengan 2 unknowns. Betul tak? So basically you can solve these 2 equation. You can solve these 2 equation to find apa? T dengan acceleration A. So bila you dah cari acceleration A, you boleh cari acceleration B. Betul tak? So tolong cari dan bagi tahu jawapan. Okay. Tolong cari. Okay. Siapa nak jadi? Okay. Nabihan. Nabihan, can you give me the answer, Nabihan? Nabihan?
Ya, Doktor.
Apa jawapan T, A dengan B? Acceleration A and acceleration at B. Block B.
Sekejap.
Okay, jangan lama sangat. Tu, cepat. tu.
I saw photo of it.
Tak tahu, betul ke? Macam tu ke cara nyanyi lagu tu? Tu. 2.
Unless I think we have to die.
What's the answer? What's the answer?
Alright, yeah. I need to find them, so I have to die. Where are they?
Ada calculator tak? Did you bring your calculator with you?
Where?
TikTok, 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 TikTok.
Where are you?
Lamanya. Tengah buat ke?
Saya juga.
Okay, sikit lagi.
Oh, for the exit, for the exit.
Saya salah masuk.
Cepat, cepat,
Sebentar
cepat.
saya tu.
Macam mana you tahu you salah masuk? Tak cerita pun jawapan you lagi?
I think this is the exit. Find the key to the let's come here. Find the key to the hidden exit door. Since I found the exit, now we have to go find the key. I call it.
Acceleration A dapat 33.3.
Betul.
Just go.
T dapat 0.034.
Hah?
Oh, lah, bro.
Salah.
Salah.
Je. 33.3.
Dad, where are you? It's so dark. Where? Oh. Something.
Macam mana?
Oh, this is a big thing. Wait, Dad, oh.
Hello.
Run!
1134.
Salah. Macam
Tak
mana
dapat.
tu? Hah?
Sekejap.
Salah ke saya punya equation?
Oh, I died. Still couple. Kenapa?
Ha? Salah ke equation saya?
Saya kira balik.
I'm the exit to the city.
9.
Wait.
Tak. Tak makan nasi?
Oh, yeah.
Macam mana? Macam mana boleh salah tu? Kawan, tolong. Dapat apa, Ti? Ni minit saja pakai kalkulator. Berapa? 327, betul. Acceleration A dapat sama tak? 3.27 atau 3.3? Dapat apa?
3.3.
Okay, acceleration B dapat apa?
Negatif 6.54.
Negatif 2. Negatif 2? Okay, ni jawapan dia. Macam mana boleh ada yang tak dapat tu? Okay, cuba balik this simple maths calculation So bila you dapat acceleration B negatif. Okay, bila you dapat acceleration B negatif, Muhammad Nur Faiz. Tadi saya tanya awak
Bukan.
Bukan, saya tanya siapa tadi? Zafran, okay. Zafran, bila you dapat acceleration B negatif, you rasa acceleration block B moving upwards ke moving downwards?
Acceleration B upward.
So acceleration B is moving upwards. Okay, sebab jawapannya negatif Sebab assumption yang you buat dekat sini, acceleration dia going downwards Okay, maksudnya acceleration A, assumption yang you buat dia betul. Acceleration B, assumption yang you buat going downwards salah. Dia sebenarnya moving upwards. Sebab you dah dapat jawapan negatif. Boleh? Okay? Boleh? Are you okay, guys? Okay. All right. Sekejap. Okay. All right. Okay. Now.
Alright, your turn.
Alim.
Just go, Tanas. Just go. I'll follow you.
Alim. Why you have to do that to him? Okay. All right. Okay.
Oh, that's the X. But we need to
Okay.
find the key.
All right. Now, next is okay. Now, so this is the way for this what I explained to you just today is how to solve the Newton second law using the rectangular coordinates. So it's very simple. As long as you able to draw the correct free body diagram and then you're able to do the equations, you can solve the problem. Okay, all right. Now, just a little bit before we finish off. So because we only have two types, another two more types, which is the normal and tangential and radial and transverse, we might finish early so that we can focus to do more questions for the next following week. So if you don't mind, can we continue with tangential and can we continue with normal and tangential? Boleh? Normal and tangential components pula. Okay. So basically normal and tangential components, what we are doing here is we are resolving the forces and the acceleration of the particles component into the tangent path and the normal path. You understand? Kita nak resolve, I've explained to you just now, kita nak resolve the forces in the tangent path and kita nak resolve the forces in the normal path. Okay, so this one akan jadi summation forces Ft, this one akan jadi summation forces Fn. Tadi saya dah terangkan kan, tapi saya just draw balik to remind you. So bila kita resolve it in the tangent path and normal path, so this one akan jadi MAT, ni akan jadi MAN. Okay, so basically what we're doing is we want to resolve the components of the forces and the acceleration in the tangent path and the normal path. Okay, so summation of forces in the tangent path dia akan jadi MAT lah, and this one akan jadi sama dengan apa? AT akan jadi sama dengan, do you remember, dVdt lah. And then summation forces in the normal direction, MAN. And then dia akan jadi sama dengan apa? Ingat tak? M, ni apa? VAN ni. V apa? V squared over? Over apa? Hello? Over apa?
Rho.
Rho. Okay, jangan lambat sangat. Are you here? Guys? Girls? Boys?
Yes, madam.
Hilang ke mana dah? Ke saya lagging, saya lambat dapat jawapan? Okay, alright. So very simple. If you have a question that is that has forces, mass, you know this is kinetics of particles, and in order for you to solve the problem, you need to resolve it into the components of T dengan N. And what you need to resolve is the forces lah. Sorry. What you need to resolve is the forces and the acceleration. Okay, now. Okay, let's do one question before we stop our class, boleh? At least one question, boleh? Nanti kita stop.
Eh,
Okay.
Well, I'll get my phone. Why don't you play this game? Just search in Roblox, search correspondence. Go to Roblox chat. I'll send you something. Go to my avatar tu. No, go to apa lah. Go to Roblox and search. Tekan search in. Dah ke? Lepas tu search Carson Dance. Car, lepas tu sun. Lepas tu letak dance. Dah ke? Tunjuk ada tunjuk apa?
Ada macam the first one like a car share that thing. Macam ada apa like a
Can you like show me? Video call. This one. This one kan? Okay, search ni lah, Carson. C-A-R-S-O-N, lepas tu space, dance.
Azim dah Azim dah 5 minutes lah.
I haven't get my phone yet, I'll go get it. Just wait. Alright, Mama, I'm gonna get it.
Okay, dah salin dah. Dah salin bagi tahu.
Doctor.
Okay, dah. Now, Alim, basuh tangan dia, Alim. Alim, bawa dia basuh tangan. Okay, alright, okay. The bob of a 2-meter pendulum describes an arc of a circle. So ni adalah satu pendulum. So dia describe an arc of a circle in a vertical plane. If the tension in the cord is 2.5 times the weight. So ni cord ni ada tension. So tension is ni adalah cara lukis tension. And tension dia adalah 2.5 times the weight W of the bob shown. Find the velocity and the acceleration of the bob. So soalan ni dia suruh cari velocity and dia suruh cari acceleration lah.
Mama, belum masak lagi lah.
Okay.
Dari cakap lagi 10 minit.
Okay, so find the velocity and acceleration. So untuk this question, obviously sebab dia ada weight, dia ada 2.5 time, dia ada tension, and then dia ada force, so it means ada kinetic lah. This is kinetic lah. And then because dia kata dia move in an arc, macam ni, dia move pendulum tu, kita tahu that this is normal and tangential. So first you kena draw the normal, the tangential, which is tangent. Oh lah, tak cantik tak. Tangent. Alah, mana? Tangent. Okay, this is tangent. And then normal macam mana? Normal macam ni lah. Betul tak? Kembali. Alah, tak cantik lah. Sekejap. I buat colour lain Colour hijau ke? Okay. So, alah, kenapa tak cantik lah? Tangan bergerak-gerak. Allah. You all lukis cantik tak? Okay, ni normal. Ini
Wait, you watch me the video di Pavali?
tension So this one normal and tension. And then apa lagi? So you dah draw the normal and tension, tangential. So you dah draw the normal and tangential. You need to draw the free body diagram
You eat first while I will go buy food now.
Okay, macam mana nak draw the free body diagram? So ada weight kan? So how do you draw the weight? The weight must be ke bawah, vertical weight. Alright. Okay, now this one will equal to what? Kinetic diagram So you need to draw the kinetic diagram as well. Okay. So for the kinetic diagram, okay. So dia macam ni juga. So ni T, ni N. So ni akan jadi apa? MAT ni akan jadi MAN lah. Betul tak? Kan MAT dengan MAN lah. Okay, ni tak cantik ni, jauh sikit. Allah. Oh, dia padam juga. Sekejap. N. Okay. Alright. Okay. So you have drawn this, then you can write down the components lah. So components kita direction dia macam ni. Ni T, then ini dia punya N. Okay. So summation forces FT. So summation FT positive direction macam ni lah. Okay. Now. Okay, if you notice our W weight is not in the direction of the T dengan N. So what you need to do? You need to resolve kan, betul tak? So you resolve satu macam ni, satu macam ni. So kalau you resolve yang arah T ni dia jadi apa? Arah T jadi mg sin ke mg theta? So kalau ni 30 degrees angle, ini pun akan jadi 30 degrees angle. So ni akan jadi mg sin theta, betul tak? Ni akan jadi mg cos theta. Guys, I'm not hearing any voices. Betul tak? What am I doing? You
Betul.
understand? Okay. Okay, alright. Okay, takut you all ni exist tak? Takut pula. Okay, so in the direction of T, kita akan ada apa? Kita akan ada mg sin theta. Lagi? Ada apa-apa lagi tak in the T direction? Itu sajalah. Okay, kita dah tak ada apa-apa lagi. Equals to apa? MAT. Okay. Alright. And then M kita tahu. M kita tak ada. G kita 9.81 sin theta. Okay. So next is kita kena buat in FN direction pula. FN direction, kita punya direction positif atas ni. MAN. So in the N direction kita ada apa? Kita ada tangent of the cable, tension of the cable, which is 2.5 the weight. Apa lagi? Itu positif lah. And then kita ada negative mg cos theta. Itu dua tu je lah. Equals to MAN. Okay, macam mana kita nak selesaikan ni? Okay, kalau you perasan M dekat sini dia tak bagi kan? Dia tak bagi Tapi kalau kita perasan M kiri kanan ni boleh potong. So kalau you nak cari acceleration T dah boleh cari dah. Acceleration T sama dengan dia sebenarnya mg sin theta divided by M sebenarnya. Betul tak? So ni dah potong dah. So AT adalah G 9.81 sin berapa degrees? 30. So you dah dapat AT. Berapa AT? Yang ni pula 2.5 mg Ini orang lain punya mg Okay, alright. So dekat sini kita boleh cari AN tak? Boleh tak? AT dapat berapa? 9.81 sin 30 berapa?
4.9.
Betul. Okey, yang ni pula tolong cari AN. Senang je kan? AN sama dengan 2.5 mg minus mg cos theta divided by m. Sebenarnya m tu boleh keluarkan kan? So sometimes janganlah pula angkat tangan doktor, dia tak bagi m. Sebenarnya you boleh potong. So AN berapa? AN berapa? Yang on mic tu kenapa tak cakap? AN apa?
33.02.
Hah?
23.65.
Salah.
16.03.
60.03.
Betul. Macam mana boleh salah tu? Okay, so sekarang ni itu dah dapat dah. So sekarang ni dia nak velocity. Okay, so kita tahu velocity, macam mana nak dapatkan velocity? Sekarang ni velocity dia nak velocity apa? Velocity dia nak at that position. So bila velocity at that position kan, at that position maksudnya what you need to do, you need to use this formula. AN equals to V squared over rho. So you need to get V. So how do you get V? Is A is square root AN divided by rho. Betul tak? So AN berapa?
130 tau.
AN 16.0.
Because I have to pack my stuff for sekolah kawan. Sebab saya dah lama tak pergi. So I have to get ready.
Dapat berapa? What do you get?
2.83.
Hah? Salah terbalik ni. You pun ikut I kan? Kita nak cari V. So dia adalah AN multiply by rho baru square root. Ayo. Kan? 16.03 kali 2 square root. So dapat berapa? Berapa?
5.66.
Okay. Now since Bob ni kan dia swing macam ni, dia patah balik. So velocity dia boleh jadi plus minus lah direction dia. Okay, sebab dia boleh go up and down. Okay. Alright, ni meter per second Okay. Alright, so this is the answer and you manage to solve. So nanti on Thursday kita akan buat untuk radial and transverse guna Newton's second law. And then kita dah habis topik awal, then we can start discussing more questions lah. Okay, so if I open dah ke? Okay ke tadi dah salin dah? Habis dah? Dah kan, sebab buat sama-sama kan, bukannya you salin ya kan. Alright, okay. Okay, so if I open the lesson plan balik, sorry, if I open the lesson plan balik. Okay. So, week 1, week 2, week 3 kita dah settle. So, the learning outcome kita dah berjaya dah. So, week 4 sepatutnya kita dah masuk topik tu, tapi kita terlambat sikit. So, kita carry forward ke week 5. So, basically kalau kita tengok kat week 4, write the equation of motion of an accelerating body. So, itu yang berjaya kita buat kan. Draw the free body diagram and kinetic diagram. Okay, done. and describe Newton's second law and apply it to solve motion of particle. So see, nampak tak? Kita punya learning outcome for today's class, kita dah accomplish. Kita dah berjaya. Dan sebenarnya kita dah buat yang ni. Solve motion in terms of tangential and normal. Okay, itu dah berjaya. So basically, Khamis ni kita akan solve motion in terms of radial and transverse pula. And then you akan dapat assignment topic 1 and 2. Okay. And then kita akan ada test. Okay. Alright. And then if you open back you punya albums ni. Oh, sorry. Albums ni. Okay. If you open back your album ni. Kalau you open the week yang ada week semua ni. Dah ada. Sekejap. Dah ada tutorial answer scheme kecuali topik week 6 rasanya. Cuba tengok week 5 kan sini ada tutorial. Okay, kalau you tekan ni ada tutorial. Ni kita dah tahu dah normal tangential ke apa soalan kan. So ni tutorial untuk week 5 kan, and then dah ada answer. So if you do the tutorial and then you want to check your answer, dah ada jawapan. So untuk each week dah ada benda tu. So you can check lah. Faham tak? So siapa yang nak buat tutorial and then nak check jawapan boleh check. Okay? Alright, you can check the answers. So dah ada lah. Dah ada answer. So answer dah ada dah. So you boleh semak jawapan lah untuk buat tutorial tu lah. Okay. So the other thing yang saya nak highlight kat sini, apa yang saya akan buat, saya nak wujudkan satu platform di mana student yang buat soalan tutorial yang nak kita sebagai pesyarat untuk semak, kita akan sediakan satu platform untuk you submit. Tapi sebab kita bagi final answers kan, final answer kita bagi. So kalau you rasa final answer you dapat jawapan yang sama, you tak nak semak, tak apa. Tapi let's say you ada buat and then you tak tahu jawapan, you tak pasti you buat betul ke tidak, ataupun jawapan you tak sama, tak dapat yang sama, you boleh submit you punya solution and then kita check apa yang silap. So nanti saya akan buat announcement dekat Telegram lah about our platform for you to submit and then kita boleh check and tengok lah. Okay, so make sure you do lah. So the more exercise you do, the more understanding you is better for you lah. Okay, alright. So semua tu ada. And macam biasa, saya kejap lagi akan stop video session ni dan link video live stream tu saya akan update kat sini lah. Week 5 lah. Week 5 part 1 and then Khamis week 5 part 2. So siapa yang nak tengok video saya tekan je. Siapa nak tengok video Dr. Raizam boleh tekan sebab ada dekat link tu drive tu. So video video saya ada kat sini. So ni yang last week tu kan. Yang saya dekat Kuantan itu kan. Ni ada video tu kan. Okay, alright. So ni dah ada, nak go through. So nanti saya update lah video week 5 kejap lagi. So ada any other questions tak? Do you have any questions? Okay, can you fill in the everyone's attendance? So you can tell me what you have learned today. So Adam, Megat, Abu Hassan, Iza, all of you, Sanur. So what do you learn today? So today I learned about kinetics of particles and what is kinetics. And then there are 3 types of coordinate system that we have to choose from. And then once you decide the coordinates to do, then only you can solve the problem. So if you want to do the rectangular coordinates, you have to resolve it in the fx, fy direction. You just write down what you understand from today's class, okay? Write with your heart, okay? So if you understand, you write and you submit attendance. So can you please fill in the attendance for today's class? And anyone have any questions? Okay, so I will stop the recording and I will download it and for you to have a look back again.